let's cover a few other points about the master. Remember that etcd is running on the master, and this holds the state. It's sort of the database of Kubernetes. Now, broadly speaking, there are two kinds of state. The first one is the desired state. Now remember, you configure Kubernetes by feeding YAML files into the master. Typically, that's done with this command, the kubectl, which is actually using a post connection when you're creating things, and that's actually the HTTP verb or method post, because the recipient on the other end is REST, and so kubectl is actually doing these REST calls. So that's the desired state. But the actual state, the real state of the running pods, may not actually match the desired state, and the actual state is found in the etcd database. And the main purpose of the master is to determine, is the desired state equal to the actual state? Most, if not all, of the components of Kubernetes are constantly trying to figure out that question. So if a node's pod goes down, the kubelet is going to contact the master, and that will update the state. And now the scheduler gets involved. The scheduler coordinates with the kubelet, and the kubelet itself actually has the definition for the scheduler inside it. And really, the whole purpose of the scheduler at all is to determine which node is going to host the new pod. And it does that by determining load. So if this has the least number, if this particular node has the least number of pods running, then this node would get that pod. If this one has the least number of nodes, this is the default behavior, then it would get the pod. To see the scheduler, you can query the services that Kubernetes is running by issuing a docker ps command, because remember, all of these VMs are still running Docker, and you will see the scheduler listed right here.